Hi, in this video I am talking about integration by parts. This is a method for finding some integrals. This is the formula we use in by parts. The integral of u dv equals uv minus integral v du. I explain by parts by giving you 6 different examples of different types. So let's see. If we want to calculate the integral ln x dx, we consider one part as u and the rest as dv. So for this case, the only choice we have is to consider u as ln x, and dv as dx. So we take the derivative on this side. We get du equals dx over x, and we are looking for v. That's why we integrate on this side, so we get v equals x. Now we apply the formula. The integral u dv equals uv minus integral v du. So we get uv, which is x ln x, minus integral v du. V du, this is du, and this is v. So it is x times dx over x. So we get x ln x uv minus integral v du, x times dx over x. Now if you simplify this part, you get the integral of dx, and you already know that the integral of dx equals x. So we get x ln x minus x plus c. Let's see one more example. The integral of x tan inverse x dx. For this question, we consider u as tan inverse x, and dv we put equals x dx. The rest, tan inverse x is u, so the rest is x dx, so it is dv. Now we take the derivative on this side and we integrate on this side. So the integral of du equals dx over 1 plus x squared. Integrate, so we get v equals x squared over 2. Now the integral equals uv, u times v, which is x squared over 2 tan inverse x, minus integral v du. So v du is x squared over 2 times dx over 1 plus x squared. Now we have to calculate this integral. As you can see, the degree of top is 2, the degree of the bottom is 2. In this case, we have to divide top by bottom or break the top. So I can write x squared as 1 plus x squared minus 1 over 1 plus x squared. And if you break this integral, you get 1 plus x squared over 1 plus x squared is 1, so integral dx, and minus the second part is dx over 1 plus x squared. The integral of dx is just x, and integral of 1 over 1 plus x squared, we already know that it is tan inverse of x. Now we put this part into the original integral, so we get I equals x squared over 2 tan inverse x minus 1 over 2, and integral of x squared over 1 plus x squared we calculated here, so we get 1 over 2 tan inverse x x minus tan inverse x plus c. Next example. Sometimes we have to apply by parts more than once. This is an application of this kind. So we name the integral as I. We use by parts once. For this case, it doesn't matter which part is u, which part is dv. I consider u as ex, and the rest dv is cosine x dx. Now we take the derivative on this side, so we get du equals e to the x dx. We integrate on this side, so we get v equals sine x. The integral of cos x is sine x. Now apply the formula, by parts formula, so we get uv, which is e to the x sine x minus integral v du, which is e to the x sine x dx. Now for this integral, we have to apply the by parts formula again. So we consider u as e to the x, and sine x dx is dv. Take the derivative on this side, we get du equals e to the x dx. Take the integral on this side, integrate, so integration of sine x is minus cosine x. Now this part, e to the x sine x dx equals uv, which is e to the x times minus cosine x, minus integral v du is minus cosine x times e to the x. Therefore, we have I equals, this is the part we already had, for this integral, it is minus uv, you already have one minus here, so you get plus e to the x cosine x, and minus integral of e to the x cosine x. We can factor the e to the x here, so it is e to the x sine x plus cosine x, and you know that this is the first integral we had at the beginning, e to the x cosine x, so we named it I, so we get this minus I. Now you have an equation in terms of I equals e to the x sine x plus cosine x minus I. So we solve this equation for I can move two i's to the left, so I get 2i equals e to the x sine x plus cosine x, and from that you get I equals e to the x sine x plus cosine x over 2 plus c. Let's see one more question. I equals in the integral of sine of ln x dx. So there is only one choice. We have to consider I as sine ln x and dv as dx. So we take the derivative on this side. The differentiation is du equals the derivative of sine. We need to apply the chain rule here. The derivative of sine is cosine, so it's cosine ln x. Now you need the derivative of ln x, which is 1 over x dx. On this side we integrate, so we get v equals x. So I equals uv, which is x times sine ln x, minus the integral of v du. V is x and du you have it here, so cosine ln x times 1 over x dx. If you simplify this, x and x is cancelled, so you get x sine ln x minus integral cosine of ln x dx. Now we have to apply the by parts formula for this integral. For this case, we have u equals cosine ln x and dx equals dv. We differentiate on this side, so we get du equals sine of ln x. Again, we need to use chain rule for finding the derivative. Cosine is negative sine ln x, then multiplied by the derivative of ln x, which is 1 over x dx. On this side, we integrate, we get v equals x. Now, from this we get I equals x sine ln x minus this integral. We use apply by parts to find it, so it is x times cosine ln x uv minus integral v du. V du is x multiplied by this and x and 1 over x times sine of ln x. Now if you simplify this, you get just sine of ln x, which is exactly the original question we had, so it's then I. Therefore, we have I equals x sine ln x minus x cosine ln x and minus I. So 2I equals x sine ln x minus x cosine ln x. Therefore, I equals this divided by 2 plus c. Another example. Before that, we need to find a method for calculating the integral of f of x times x, where f of x is a polynomial and you can take the derivative of that, and g of x is a function that we can find its integration. So we use two columns. On this column we calculate f of x and its derivatives, and this column we write g of x and its integration. So we take the derivative f of x, suppose it is f1, then f2, then f3, and if it's a polynomial you get 0 finally. And on this side we integrate, we start with g of x, then the integration of g of x, the integration of g1, the integration of g2, and we continue until we get gn of x. Now the formula is that if we connect f of x to the second one, not to the first one, g1 of x, f1 to the next, and we connect f2 to g3, f3 to g4, and so on. This is the formula we can apply here, and also we put plus minus on this, and this is the formula. The integral of f of x, g of x, equals f of x times g1x. You have plus here, so it's plus, then minus f2 g2 plus minus f1 g2 plus f2 g3 minus f3 g4, and so on. Let's see one example. Suppose we want to calculate this integral x to the 4 cosine of 2x. So in this case the polynomial is x to the 4. On this column we write x to the 4 and its derivative. On this column we write cosine 2x and we calculate the integration of that. So the integral of cosine 2x is 1 over 2 sine 2x. Then we integrate again. We get 1 over 4, negative 1 over 4 cosine 2x. We integrate again. We get negative 1 over 8 sine 2x. Integration is 1 over 16 cosine 2x, 1 over 32 sine 2x. On this side we write x to the 4 and the derivatives of that. So x to the 4, 4x cubed, 12x squared. Take the derivative, you get 24. And finally you get 0 because it's a polynomial, you get 0 at last. So the formula is this: connect the first one to the second one and put plus on top of that. So it's plus, next is minus, next is plus, next is minus, and the last one is plus. So the integral equals this times this with plus, this one times this one minus, and then plus 12x squared times negative 1 over 8 sine 2x. Next is minus 24x times 1 over 16 cos 2x, and finally plus 24 multiplied by 1 over 32 sine 2x. So we get the answer for this integral. If you want to apply by parts, you need to apply by parts 4 times for this case, but if you use this formula you can get the answer quickly. The last example, suppose we want to calculate the cosecant cube of 2x dx. We need to use by parts, but how? We break cos cube 2x into cosecant cube 2x. We break it into cosecant 2x times cosecant square 2x. Now, we consider u as cosecant 2x. So the derivative, we need the derivative of cosecant. You know that it is minus cosecant cotangent and multiplied by the derivative of 2x, which is just 2. So the rest must be dv then. For this case, dv equals then cosecant square 2x dx. To get v, we have to integrate. So v equals the integral of cosecant square 2x is minus cotangent. The integral of cosecant square is minus cotangent. Because of this 2, it is minus cotangent 2x divided by 2. Now if we apply the by parts formula, we get I equals u times v, which is cosecant 2x multiplied by negative cotangent 2x over 2 minus the integral of v du, which is cotangent 2x over 2 multiplied by cosecant square 2x. Okay, now we can simplify this into cotangent squared is cosecant squared minus 1. So if we simplify this, we get cosecant squared minus 1 times cosecant 2x. Expand this, we get minus cosecant 2x times cotangent 2x over 2. And here if you expand it, cosecant squared multiplied by cosecant, you get cosecant cubed. And remember, we named it as I, so it's minus I. Then minus minus is plus cosecant 2x. And we already know the formula for the integral of cosecant 2x. It is ln of absolute value of cosecant 2x minus cotangent 2x, and because of this 2, we write 1 over 2. Now we are looking for I. We move 2 i's to the left. So we get I equals finally this divided by 2 plus c. Okay, thank you for watching. Goodbye.